Or you could do your inverse norm, ladies. So the one calculator step that all my classes always use is inverse norm. Sometimes you find that area in your chart, that's not bad, but sometimes you kind of have to do a little extrapolation. Which one is it closer to? And it's annoying to have to work in that chart. So inverse norm works really nicely. Second bears number 3. And the reason we say inverse norm, it's kind of like when you did your tree. If you said sine of 30, it gave you 1/2. If you knew that the sine of an angle was 1/2, and you had to find the angle, you did the inverse sine. So it's the same concept here. We get a z-score, we can find your area. Give us the area, we do the inverse of that table to find the z-score. So these are all your areas to the left. Now, it does make sense when you do this. If your area is bigger than 50, larger than 50%, then your z-score has to be positive. If your area is less than 50%, then your z-score has to be negative. Okay? That's why I think that the sketch is a big help. I realized it was kind of redundant to sketch because most of you just did the inverse norm. But if you kind of get the position of it by sketching, you know then is your z-score positive or negative. It kind of gives you a good feel. This one is less than 50%, so it's got to be negative. More than 50%, positive. Okay, I think most of them just went all your areas to the left. 0.05, it's a small area to the left, greater than 50. There's your percentile. This is at the 1%. Make sure you convert this to 0.01. And you could not put it in as 1 anyway. But here's a 40, 0.40, and you're still less than 50%. Your area is still to the left. Are there any questions on this? No? This is really helpful because the next part of this, we're going to be finding those x values that correspond to this. And that's probably one of the most used things that statistics uses. If they have something there and they can say, I want to know what the cutoff is for my top 10%, for my lower 10%, for where my cutoffs go. What's half of my field out there? This is a good way to find it. Okay, and the rest of your percentiles. Remember, all your percentiles go from 0 to 100. This is like when you took your standardized testing and you got a 75% on your reading comprehension. It didn't mean you scored 75, it means you did better than 75% of the class. So your percentiles read left to right. Good so far? Or just not so hard? Okay. You've got number 25. They gave you a little sketch, and you've got an area to the left. Same thing you just did up top. Do the inverse norm, put the area in, get the z-score. Area to the right is this way. So you can only look up this one. If you ended up with a positive z-score, all you need to do is notice that the negative one is symmetrical to it. If you look this up if you looked up this, you got the area to the left. You got this z-score. Remember, this is a symmetrical graph, but it has to be area to the right. You have to have a negative z-score on this. So you have 2 ways to do this. You can look up this one and then flip the sign over to the negative side. Or when you do inverse norm, since you're looking up the area to the left, let inverse norm do your subtract. Just put this in inverse norm. 1 minus that. You don't have to do the calculation first. Stick it right in inverse norm. Everybody good with that one? Do you see the symmetry in the chart? If you did look up the positive, if you looked at the 0.7190 and you got the positive value, that you have symmetry in your graph, right? Symmetry about the mean here. Okay. probably one of the hardest concepts is the symmetry concept. When it's the area to the left and the area to the right, that you can use your chart. It's weird. I'll explain it. Some kids will catch it. And then out of the clear blue, I usually get somebody that says, oh, could you just say negative 0.05? And it's just like, you got to see it yourself to say, oh, I got it. Now, when you're doing this in both tails, all you need to do is find me one z-score because this is symmetric. It's symmetric about the mean. So I look up the 0.05 and I find this z-score, and this one has to be the positive one. So you've got a z-score of plus or minus 1.645. Okay? It's got to be the same on both sides. This is a great example of your symmetry in your normal curve. Good? Okay. All right, 62%. And here's another one. Same percentage, one to the left, one to the right. They have to have the same z-score. It's covering the same area. So when I'm looking at my to the left, this is greater than 50%. I look this up, I get a z-score of 0.33. If I want the area to be larger to the right, I can either do the inverse norm, 1 minus this, or I can realize that this has to be symmetrical. So where I had the other one there before, it will be symmetrical on the left-hand side. You can just make it the negative. These exercises were good because it's forcing you to look at the symmetry. Even if you don't see it, once you kind of find your answers, then you kind of say, oh, it's the same number. So, with the opposite sign. So it kind of makes you look at it a little bit better. Everybody okay with those two? Yeah? Okay. Stop me if you're not, guys, because this is important that you get this. Here's what we did the other day with the area in between. The area in between is 80%. It shares 20% left over. So like the other one, I only need to look up one side. So if this total is 20%, half of it is 10. So just look up the 10. And you can even do this in inverse norm if you put parentheses around it. Do that and then divide it by 2. You can do that right in inverse norm. I want to see what's left over and I want to share it because I only want the left one. Inverse norm will let you do it right in inverse norm. That's the nice part about that function on your calculator. You don't have to first go to put it in. It's kind of nice. And remember, whatever z positive you get the z, or the z negative you get the z positive as well. Okay. And I think this was the last one, another in between. If in between is 0.05, then you subtract it from 1, divide it in half, and you look up the left side. And that will give you your symmetry. Any questions? Okay, tomorrow we're going to continue with this and find the x-scores for this.